Good morning. Can you hear me all right? Okay. I'm delighted to be here. Thanks so much for bringing me out. This is my first public broad audience lecture in some time. And given that we're at the Humanities Festival, I wanted to make a little bit of a reference to Maimonides, Rambam, who I'm told was kind of, my historian friends tell me he was kind of important. But really this title is a pun, and the pun will become more clear as we make our way through. Let's start off with ChatGPT. You've heard of it? Yeah. So this is the fastest growing application in history with over 100 million users. This particular system and ones like it can do things like engage in conversations, answer your questions, write code, play games, translate text, summarize text. They're basically extremely fluent machines. And when they arrived, there was a lot of confusion, particularly in the scientific community. People in our larger society are asking how they're going to change the nature of work, how should educators respond to the potential for cheating in academic settings, how can we reduce or detect the misinformation that they sometimes produce, how do we, I don't know, in my world, it's all about what does it take to build these systems. But basically, we in the field of artificial intelligence are baffled. We haven't seen anything like this that's been so quickly adopted, so much discussed in the press, and the claims that people are making are so bold. And, to top it all off, you sit down and interact with one, and they're just shockingly fluent. I don't know if you've had this experience. So I've started talking about them as fluency machines. And I think that idea is kind of interesting because when, we all interact with other fluent creatures every day, other humans, right? But that fluency, in our experience, has always come packaged together with other aspects of intelligence, social intelligence, and there's a whole lot more to being human than just fluency, but these machines, they just have the fluency. So questions like, philosophical questions like, are they intelligent? Are they more intelligent than humans? Are they intelligent in the same ways as humans? And if the behaviors are in some ways indistinguishable from human behavior, does it matter if they were obtained or carried out differently than the way humans have? I don't think those questions are actually as important as what do we want them to do? What do we want them to not do? How successful are they going to be at doing what we want them to do, and how readily can we discover when they fail? So I'm hoping that our discussion will help lead you to answers to these questions in time. So let's talk a little bit, let's get some terminology out of the way. So ChatGPT is one example of a system, probably one of the most successful ones. It has been marketed as artificial intelligence and advertised as AI. The core technology inside is called a language model. And that's the thing I'm going to focus on today. And I'm going to try and give you the perspective of a researcher and educator to add a little bit of clarity beyond what's currently available. Right now, you can easily find technical papers that give potentially a lot of detail about what's going on inside. You can also find a lot of promotional materials, which I view as basically advertising from the companies that are making and selling these products. What I want to do is a little different. So I'm going to try and demystify what's going on here with language models. I'm going to try and tease apart the concept from the products, the behaviors that they display, the claims of similarity to humans. There are a lot of metaphors you can read about these. It's just, I can't even keep up with how much is being said in the press about these technologies. People have compared them to bureaucracies, to markets, to demons, to blurry JPEGs of the web. I'm not going to give you a metaphor. I want you to build your own, okay? So here, and I think, with wider understanding of this technology, like other technologies, there's a greater chance that we can harness and democratize the benefits and guide policy in sensible ways to protect from the potential harms. Okay, so here is our plan, and I'm going to start off by giving you some tools from my research community. So the natural language processing community, or NLP, is the field in which language models have emerged. So language models didn't come from nowhere. There are no mad scientists. We're all very nice people. They are the result of many years of research. In fact, NLP has been around since the 60s. And I would say, if there are other people from the field here, they might argue with this. I think one of the fundamental questions we ask is, in what ways can computers understand and use natural language? And this has mainly been approached by attempts to build computer systems that show language understanding and language use behavior, like holding a conversation with a person. And I think taking some of the terminology and questions and problem-solving methods that our community uses in research will be helpful in advancing your understanding of language models. Okay, so the first tool is, I call it taskification. Suppose that you want to build a power plant. You're going to need to talk to some engineers, and those engineers are going to require a really precise statement. How many kilowatt hours are going to be produced? What's the budget? What are all the laws regulating the construction of power plants here in your community? And what are, how do we guarantee safety? There's a whole lot of very technical questions you have to answer before you go about building a power plant. And I would argue that it's actually harder when it comes to NLP systems. I can do this because my father was a nuclear engineer. I can say this is harder. Each of these high-level applications, like the things you see on the slide, these are aspirations that we've had in the field of NLP for many years. But each one leads very naturally, and I'll give one example, to a whole bunch of more detailed, fine-grained technical questions. So translation between language, this is what got me into the field. It's such a beautiful idea because it's hard for people to communicate when they don't speak the same language. Could technology help us do it? But as soon as you start talking about building a system that can translate, you get to these questions, specifically what languages, what writing conventions. Is it going to be like newspaper text? Is it going to be like Twitter? How long are the texts going to be? Does it have to happen in real time, like at the UN, or can we do it with some offline processing? So basically, there are always going to be some narrowing assumptions when we set out to build a system. They might be temporary, they might be very long term, and so I would just point out, think of something like engaging in a conversation. Think of all the questions we might have about a system that's supposed to engage in conversations, and you're going to have to make some assumptions. Is kind of my point. So when we set out to build a system, what we do is we create something called a task, which generally means you have to have two things. You have to have some data that you're going to use to evaluate how well the system performs. And you have to have an evaluation method that makes use of that data. So the data is usually going to be a set of demonstrations of inputs paired with the outputs we want to see. And in my example here, we have example in French-English translation. We can get data. Originally, one of the first places they got data was the Canadian Parliament, which by law has to produce all of its proceedings in both English and French. So your inputs might be these sentences in red, and the outputs might be the ones in blue. The way we might evaluate is we look at the system output on some of these inputs and compare it to the example outputs and have humans make a judgment, or maybe use an automatic scoring method to judge how close the system output is to the target in blue. Another task that's been studied widely is taking a movie review and analyzing the sentiment and judging how many stars. So if you say that there's so much to latch onto in this movie, so much for each member of a family that watches it together to love, this sort of has a positive sentiment, and maybe the right answer is it's a 5-star review. On the other hand, if someone says at least we know there won't be a sequel, it's a 2-star. It's not so good, right? So I want to be very clear, though. A lot of people have worked on this kind of sentiment analysis task, and we often talk about it as sentiment analysis. But if you build a system that does this solves this classic problem, it probably won't work on restaurant reviews or electronic product reviews or novel reviews. Because the language that people use to say what they like or don't like about a movie is partly language about movies, and it won't carry the same meaning in a different context. So if somebody builds a system that does movie review sentiment analysis and performs pretty well, they shouldn't then claim it understands sentiment, because sentiment is a bigger thing and it might be different in different contexts. So understanding the scope of an evaluation that someone does to argue that they have a system that displays some intelligent behavior is really crucial to knowing what to expect in terms of how well it will generalize and whether the comparisons to earlier systems are fair. And if two evaluations use different demonstrations to measure quality differently, the comparison won't make any sense. Okay, so high-level point, mind the gap. In research, we often make this sort of tacit assumption that improving task performance will generalize to other tasks. And the research community tends to share these assumptions, and generally, on the other side of things, deployable systems require a whole lot more rigorous testing with actual users before we can make claims about what they do. So task performance is only part of what you want in a deployed system. You also want it to be fast and have intuitive user interface and generally respect the cultural norms of the people using the system. So in general, please be mindful of the gap between aspirational capabilities that motivate researchers and these taskified versions of problems that make it easier for us to measure progress. I'm not saying one is good and one is bad. I'm saying that there's a difference. And as research advances, and due to the tension between these two things, the tasks and the data sets and evaluation measures are always going to be in flux. So the examples I gave you are very classic tasks that have been studied in natural language processing for 20 years or more. Okay, so I want to say a little more about data. This is tool number 2. Getting data is actually a much bigger issue than I suggested above. The examples we had were cases where either a public entity like the Canadian Parliament makes nice data available for the NLP community, or the public internet shows us many examples of what we want. But for most NLP applications and most tasks, there's no easy source of data. And in fact, this is frustrating because the best known techniques for building systems require having not just data to evaluate, but also huge amounts of data, as much as you can get to help build the system. And we'll say a little bit more about that. We call this training data. And there's one key point I want to make about training data. People like to go on and on about data, but they never say this often enough. There's one rule about experimentation in NLP and evaluating systems. The evaluation data can't be used for any purpose prior to the final evaluation or test. For example, you can't use the evaluation data when you train your model, when you build your model. The analogy I like to give, I'm a professor, pardon me, it's a student who somehow got access to the answer key to my final exam. Now, I can't assume the student read it, I can't assume they cheated, I can't assume anything bad about the student's character, but if the student takes the test and I find out that they had access to the answer key, the whole test is invalidated. It doesn't matter how well they did. I can't assume that they actually understood the material from the class. So this is very important. Occasionally someone will discover a case where this rule was violated, and regardless of intent or the awareness or anything else, the conclusions of any dependent research are immediately treated as unreliable. This is the cardinal rule. All right. I also want to give another example of a potential task. You could imagine this. Actually, somebody once asked me to do this. It was another academic department. We get recommendation letters. This is part of the currency of academia. We write these letters and send them and read them and make decisions about who to hire, who to take on as a student. Imagine someone came to me and said, we'd like your help building an NLP system that would essentially read all the letters and tell us which students got positive, were positively reviewed. And I said, okay, well, the first problem here is, where do we get the demonstration? You could, this is actually a pop quiz for you. You could tell me now, given what you know now, why we can't do this. Letters are private. You're not going to find them on the internet, and if you do, they were either put there unethically or they're fake. Letters are also very complex and multidimensional. Getting to a simple rating of a letter is very, very hard. And if we could do that, then why didn't we just ask people to give ratings instead of writing whole letters? So needless to say, I declined to work on this problem. And so, basically, whenever somebody talks about a potential task, my immediate question is, where do we get high quality data that will let us do reliable evaluations and ideally also train a system? Separate data for training the system. Okay, the third tool, and this is a term you may have heard before, is an entire separate research community or overlapping research community called machine learning. It's also a body of knowledge. I could teach you a whole semester about machine learning. I'm going to give it to you in like 3 slides. The key idea is that you have something called a parameter. And I want you to think of your system in a physical way. I like physical metaphors. Think of a knob on your system that you're trying to build. And turning the knob is going to affect the behavior of the system, including how well it performs on the task. So to make it concrete, let's consider another task of filtering spam email, something we all hopefully benefit from every day. So due to budgetary constraints, our system only gets one parameter. And here's how it works. It scans an incoming email and increments a counter every time it encounters a bad word. And we'll just say, because we have to define bad words, we'll take the 7 words that George Carlin said he couldn't say on television. We could change that list later, but okay. If the count is too high, the email is sent to the spam filter. Otherwise, it goes to your inbox. How high is too high? We need a threshold. That's our parameter. And so we have to set the parameter appropriately. If we set it too high, nothing will get filtered. If we set it too low, then too many messages may go to spam. Important messages might go to spam. So the threshold is an example of a parameter. Okay, so that example neatly decomposes the system building problem into 2 separate parts. First, what parameters does the system have and how will they work? And then the second thing is how do we set those parameters? So in a typical system, which we often call it an architecture, and often today the architectures are a special thing called a neural network, which is really just a special kind of architecture with a whole lot of knobs. So here they're like dials. I like this kind better on my stereo. But you can imagine having lots of these knobs. And so designing the architecture and deciding how your system is going to work, how the parameters are going to affect what the model does in terms of inputs and outputs, that's one problem. And the second one is setting the values of those parameters, turning all the knobs. So the other part of machine learning is procedures that use training data to automatically set the parameters, all of them in parallel. And there are today systems with billions, even hundreds of billions of parameters. So picture a really big box with a whole lot of little knobs, or a cockpit with a whole lot of little controls, and imagine that you've got this fantastic tool that can kind of use the data to decide how to set all the knobs, hopefully fairly quickly. I have to mention that it's really important to have the right hardware to do this. We can do machine learning on that scale today. We couldn't just a few years ago, thanks in part to advances in computing hardware. So this is called a graphics processing unit, a GPU, and that's the main tool that we use now to build models based on neural networks in natural language processing and many other areas of AI. It may seem a little counterintuitive that we're using a graphics processing unit here because we're processing language, not graphics. But it turns out that the same calculations that GPUs do for your video game graphics are also used in setting neural network parameters. And so I would say the realization that neural networks were well suited to train on GPUs proved to be crucial to allowing us to put way more data through and much more wide adoption. And so these things are a really hot commodity right now. My graduate students want me to buy more of them all the time. Okay, so that's the background. I want to move on and talk about the language modeling task. So I've given you some tools that will help you to make sense of language models. But the next part needs to come from your own abilities. And so this intuition is going to come to you, I think, very naturally as a person with hopefully some understanding of the English language, or you haven't understood this talk so far. We're going to play a game. I'm going to say some words. I'm going to stop. And I want you to think for a second, guess what word will come next. And then I'll point, and if I point at you, I can't really see you. The lights are extremely bright. So I will point at what I think is a person, and that person will say the word, and we'll all applaud if they get it right. Are you ready? All right. By the pricking of my thumb, something wicked this way. Think about it. Think about it. You with the glasses. Comes, correct. Good job. All right, the new House Speaker has put his faith at the center of his political career and aligned himself with a newer cohort of conservative Christianity that some describe as Christian. Think about it. Think about it. All right, I'm going to call on the smiling lady in the second row. Extremism? Not quite. It was nationalism. Sorry, no applause. Okay, one more. The risk of a wrong decision is preferable to the terror of... Anyone? Shout it out. Indecision. That's from Rumbaugh. Okay, so you just showed me that you are language models. The language modeling task is essentially to take a sequence of words as input and then output the one that comes next. That's it. It's essentially like autocomplete. You've probably used something on your phone or in your email that did just this. And so, first I'd say it is a task in the sense that we have evaluation and training data, and we have an evaluation method. I'll talk about both of those. The cool thing about the data is that it's actually really easy. All you need to build a language model is lots and lots and lots of examples of words that came next, or words with their context. And the internet gives us massive amounts of that. But I want you to think about what makes it possible to predict the next word. Some of it is about knowing the structure of the language. Some of it is about knowing the topics that we talk about. But I think there's actually more to it. So language models are just like fantastic for modeling fluency. Good predictions follow from some comprehension of the rules of grammar. And in fact, these things have been used for many years as modules in larger systems, in translation systems, in speech recognition systems. Language models, that's how I learned about them in graduate school. They were the fluency module, but they worked alongside other things. But you can probably do these too. The Declaration of Independence was signed by the Second Continental Congress in the year 1776. You could have said 1501. That would have been perfectly fluent. It just would have been wrong. There's something about your knowledge of history that influences your predictions. Also, when the boy received a birthday gift from his friends, he didn't feel like going to sleep. He didn't feel angry. And you didn't say those things because you have some common sense, right? You understand what the language means. So basically what we're observing is that at least some simulation of this like knowledge and common sense and reasoning and things like that seem to come about when you build a language model that predicts the next word. So basically things have shifted a bit, and since about 2018, we've moved away from the language model as a component in a larger system to the idea that you first train a language model just for the language modeling task, and that's a large, expensive enterprise, and then you maybe tweak the parameters a little bit for the task you really care about. Or maybe you don't even have to tweak them, and basically what it turns out is that you don't have to do very much to get the language model to do other things as well. I want to make one caveat. I said that getting the data was really easy, and in fact, when we build language models today, we tend to use things like news articles and books and Wikipedia. And the interesting thing about this kind of text is that it's all been kind of carefully edited, and it tends to reflect, a certain kind of professional writing at its best that maybe isn't reflective of everybody's language and the way everybody talks all the time. Also, there's a lot of explicit filtering. So usually we focus on building a language model for one language like English, and other things get filtered out, or maybe we avoid some topics. If we know the language model might be used by kids, we don't want erotica in there. These filters are automated, and their design is not a totally solved thing, and they can actually have a big impact. And one of the things we found is that whole groups' language can be diminished or excluded as a result of this kind of filtering. So it's not a completely solved problem figuring out whose language to include, and it seems to have an effect on how the models work. Okay, I promised you that there would be an evaluation method too, that language modeling was a task. The math is really beautiful, but my graduate students talked me out of including it in this talk, so you can thank them. We have a score called Perplexity, which I like to think of as model surprise. I'll try and illustrate it. The way that language models make their predictions is they assign probabilities to all possible next words. Everything in the vocabulary is kind of on the table, and the model puts probabilities on all of them. And so the question Perplexity asks is how much probability went to the correct word. We're looking at new evaluation data. If the model, and we want to know how well the model predicts what comes next, so we can look at the correct word and say how much probability did it get, and if the model gives very low probability to the correct word, we say the model was surprised, and this is sort of a bad sign. The model isn't predicting well, so it is perplexed, it is surprised. On the other hand, if it puts a lot of probability on the correct word, then it was unsurprised, and we are happy. And so perplexity is basically a transformation of an aggregation of this kind of surprise measure over many word predictions. And the cool thing about it is that we can measure perplexity with only text data. We don't need human judgments, we don't need labels, we don't need special research on automatic scores. That's pretty nice. Okay, so to summarize, here's how you build a language model. You get as much text as you can that you believe will be appropriate for the thing you want the language model to do. You set aside some of it as evaluation data and you don't use it. You break the text into a sequence of words. You train a language model or set its parameters using those magical GPUs and the machine learning tricks. It's just math. And then evaluate by measuring the perplexity on the evaluation data or measuring how well the system does on the thing you wanted it to do in the first place. That's essentially the recipe. Okay, but we wouldn't be talking about all of that if that was the whole story, right? Why are you hearing about language models now? They've been around since the 60s. All of that stuff, Perplexity started getting used in the 80s. What's interesting is that now it seems like fluency is getting us most of the way. Language models don't really need other modules alongside them to be useful. The rise of data, I think, is really important. We've known since the 90s that more data helps. But it's just getting easier to collect it. There's more stuff on the internet. There's faster progress, particularly for languages that have a lot of data on the internet. If you speak a language that isn't, where data is a little harder to get, you probably haven't seen NLP breakthroughs quite as fast. The other piece is a particular kind of neural network architecture called the transformer, playfully named after the 80s toys. I didn't have them. Other kids had them. I wasn't into that. But I knew what they were, so I get the joke, I guess. And also, with the increase of availability of GPUs and faster GPUs, the transformers have gotten larger, just meaning there are more parameters in them, more and more. So think of more and more knobs, billions, hundreds of billions of knobs now. And these things all kind of happened at the same time. Larger data sets, faster hardware, larger models, they all kind of depend on each other. And you can't, if you have any one of them, you kind of need the others. Teasing this apart would require extensive, expensive experimentation. So if you ever hear a simple answer as to why this stuff is working so much better, it's probably wrong because we don't know. We can't tease these things apart very well. The science is still evolving. I guess the other reason is that the Chicago Humanities Festival did not invite me to speak here in 2013 or 2003, or I could have talked about them then. Might not have been as interesting a talk. Would have been more math. Okay, lots of impacts. We've said they're very fluent. You've observed this if you've used them. In the field of natural language processing, many of the old tasks we used to work on, translation, sentiment analysis, they can now be accomplished with basically just next word prediction. And because so many more tasks are now opened up, there are so many more users. There's lots more people interacting with this technology than I would have ever thought would happen in my career. Because they've gotten so big and they have so many billions of parameters that we can't understand. They're not like that naughty word George Carlin threshold. Now they're like, we don't know what any one parameter does. We don't have good ways to see. So we call them big black boxes. And because they're so expensive to build, not everybody can build one. So I told you how, but you are going to have to shell out a lot of money for GPUs and engineering to get this working. Language models are becoming centralized and proprietary because only a few companies have the resources to build them and make them competitive. And they're turning into commercial products because people see them as useful and they're being tuned to do what's often billed as general purpose instruction following. So people do a little bit of fine tuning at the end to try and make them helpfully engage with you to do the things you say instead of just predicting the next word. But the fundamental thing is they're still predicting what comes next. I would say we need to talk a little bit about some safeguards. Given that these models are trained on such a wide variety of content on the internet and we don't manually filter it, we don't know what all is in there, models can create outputs that contain unsafe content. You could probably, if there weren't steps taken to prevent this kind of thing, a user might ask how to create a bomb or help them plan some other dangerous or illegal act. I would say whether these models are intelligent or not, they contain and know how to present this information to people. And so that creates a risk. And so there's a lot of discussion about how you create safeguards. There's a huge amount of research on this. Sometimes the models are tuned to avoid some topics or, to block hate speech, for example. I think there are a lot of less obvious cases. For example, the models have a lot of medical knowledge. They've read all the medical papers, but probably you shouldn't take medical advice from a language model. You should probably go to a doctor. And so if somebody asks, the model should disclose, I'm not a doctor, I'm not reading the article right now online, right? there's another, I don't know, there have been examples of involving self-harm that are somewhat disturbing. I think the necessity of these safeguards is very easy to see, but depending on how they're implemented, it's important to note that they can impact how well the model works. So if you're just like our threshold, right? If they're too strict, if there are too many constraints, then the model may become less useful. And so there's a tension. I'm not going to tell you where we should put that bar, but there is a tension between cautiously avoiding liability for model developers and making users happy. One of the other byproducts I like to mention is that we've been measuring performance on NLP tasks for many years. It's kind of, the thing we always put in our research papers is this table showing that you beat the other systems. But almost every way that we measure performance, we've seen improvement using these new large language models. But remember the gap between what we can measure and what we really care about. And I want to return to that for a second and say that the tasks always need updating. And in fact, what we're finding is that the things we were measuring in years past those tasks don't look a whole lot like what people really want. Now that people have language models in their hands, they're doing things we didn't expect. And we don't know how to evaluate all those things. We don't even know what all those things are. So I think, my view is that customization of these models is going to become increasingly important as we look at very diverse users. And no single number is ever going to capture the full set of things that we want these models to do. So evaluation, we need it. We absolutely need it. We have to hold ourselves accountable and measure what systems do, but it's always a moving target. There's a particular challenge I also want to mention as the data sets have gotten really large. The capabilities of the models really depend directly on the data that was used to train them. And the kind of rule of thumb I think you should have in mind is that if you give some instructions or make a request to a language model, the closer that language is to something the model was trained on, something it saw before, then the more likely it is to mimic reasonable continuations of that kind of language and maybe perform successfully at the task. Conversely, if the language of some text is really, really far from what the model was trained on, then the less predictable its continuation will be, and that's where you get kind of unexpected random behaviors. And this has led some people to use the metaphor of parrots when talking about language models. And one of the annoying things about this is that the data itself is often treated as a trade secret. So we don't know exactly what data was used to build ChatGPT. And so, back to that point about cheating on the test. Whenever somebody shows me some very surprising, capability that the language model has, I'm never really totally sure to believe it if I can't go check whether this example or something very close to it was in the training data. So watch out, the student might be cheating. Okay, I want to give you some practical points because you might be using these models. First off, the way that you word your request might matter. So people in my research community have spent a lot of time looking at how changing the wording of the prompt can affect how well the task is performed. And so basically, if you try a few different versions of your request, one of them might get closer to something the model has seen and might give you better results. So just kind of a handy tip to maybe help you get a little bit more out of these things if you're using them. Second, that people talk a lot about hallucinations and truthfulness. And I want to be very clear. These models, they don't do any kind of explicit fact-checking or access the original sources. There was a lawyer who got into hot water for using ChatGPT to write a legal brief, and it cited cases that didn't exist. And I'm not a lawyer, but I know you're not supposed to do that. And the lawyer didn't understand that there wasn't a search engine in the background, like checking the cases. And I have a little bit of sympathy for that because where in OpenAI's documentation of ChatGPT does it say that there's no search engine there, right? They don't really say a lot despite the name. They're not very open. So the summary of this is language models don't perfectly capture their training data. There's things get fuzzed up a little bit. And so, also there are contradictory statements in the training data. Lots of different people say things on the internet that don't all form a consistent, coherent worldview. And so it shouldn't be surprising that the models won't necessarily give consistent, correct outputs. Another point, and we could talk a lot more about this, but there are quirks in the data. The data emerge as the byproduct of culture, and there are all kinds of quirks. Like we've noticed association of some words with some dialects, unsurprising. This happens with humans as well. There was one example we wrote about a few years ago about a tendency for toxicity detectors that look for toxic language to be much more likely to label African American language, African American English as toxic. This isn't about African American English. This is about that data set that it was trained on and the labels that were given by human annotators. But that passes on to models. There are lots of examples of a tendency for models to predict physicians to be male or sheep to be black. Why black? Most sheep are not black, but there's more in the text. There's more discussion of black sheep than of other kinds of sheep because black sheep are special and there's an extra meaning to black sheep, right? So bias is complicated. It is not a solved problem. And so, again, I've said several times, the idealized task is kind of far from or the task that we actually try to solve and measure performance on is somewhat far from the idealized task, and the data is also removed from both of those. So the data is never perfect. Okay, this is a big one. People like to talk about the emergence of human-like or superhuman intelligence, and I'm gonna say something that's maybe a little bit unpopular. I'm gonna say I think this is unrelated to the practical concerns of users. There was a fantastic talk at the main research conference I go to every year by the psychologist Alison Gopnik this summer. And I'm going to give you a quote. This is just wonderful. In cognitive science, she said, it's widely understood that there's no such thing as general intelligence, natural or artificial, but rather many different capabilities which cannot all be maximally attained by a single agent. So I think this is really, really kind of fascinating. She proposed that we should think of language models as more like writing or print or libraries as a cultural technology. I found this quite compelling. I think, but she also kind of forgave us for anthropomorphizing the language models and thinking of them like people. She said people did this with writing in the past as well, and talked about how people thought about written text as autonomous, unthinking agents, which I didn't know. I'm fascinated. Anyway, you may have heard this term, artificial general intelligence. I'm just going to say it is not a well-defined scientific concept. There's no agreed upon test for AGI. The term should be understood as marketing. It's like saying that detergent makes your clothes smell fresh, or that a car is luxurious. I would recommend assessing more concrete claims about specific capabilities using the tools that I've given you. No product should ever be expected to do anything you ask, and the clear demonstration that it can do one thing well shouldn't be taken that it has broader or other capabilities. Remember, these are just fluency machines. They aren't like people. They don't come packaged with all the other intelligence. I don't know. So I would say I'm far more excited about tools that will augment human abilities than about thinking of these things as agents that are going to be kind of like competitors to humans. Also, I'll just say this again. If it's cheating, it's not intelligence, and we don't know if they're cheating. Okay, so final point. Analogies to human capabilities never perfectly capture or describe the capabilities of language models. They were not exposed to what you've been exposed to. They don't have the biology and the world experience that you do. Just don't think of them as people. Okay, I have like 4 minutes left to talk about the future. And that's really hard, as some people have said, Niels Bohr, Yogi Berra, maybe. I'm not sure actually who said this. I think this one's contested. Maybe they both said it. This field is still in its infancy. 1960s is when people roughly started doing natural language processing, and using large language models to do this is extremely recent. I think the lack of transparency is a real problem. But I'm optimistic. I actually think decentralizing these tools and democratizing their benefits is within our grasp. I don't want to talk about regulation. I'm not a lawyer. I have a lot of notes here in case somebody asks me a question, but this topic terrifies me. I mean, yeah, okay, I'm just going to skip it. What I would rather talk about, rather than talking about what we can hope that our policymakers and legislators will do in the current climate, that seems extremely optimistic. I want to talk about maybe what you can do. So if you're a student who finds this topic interesting and you're interested in AI systems, then become one of the people helping to decide how they work. And so for anyone in this position, I would recommend studying computing, math, statistics, also fields that reason about society. This is not a purely technological thing anymore. The question of what we build these systems to do deserves just as much attention as the question of how we build them. And people who understand both are extremely important. If you happen to have some expertise in some discipline, then I would say that the people building these models could really benefit from that expertise, from your expertise. Determining how to adapt AI systems to assist safely with problems faced by experts isn't something computer scientists can do on their own. We don't know what you do. So to make these kinds of models useful for you and your field, and to avoid trying to solve problems that don't really need solving, which is something computer scientists are really good at, model developers are going to need your input and help. If you make decisions in a business sphere, then my recommendation is to set a high bar for evaluating possible AI-based solutions in your world. I think there's a lot of flashy language out there about some of these systems. By ignoring the flashy language and instead engaging with developers in discussing how a particular system was tested and how well that testing relates to your own intended use case for it, and what's missing from those tests and helping to develop better ones, you can raise the overall standards. And let's see, policymakers, I guess, my main recommendation is come talk to independent scientists. It's great to talk to scientists at the big companies. They can tell you things. They can tell you things the rest of us can't. But also talk to independent scientists who are not aligned with particular purveyors of technology. And finally, for everyone, the one thing I think you can do is be a thoughtful consumer of the news. In recent months, there's just been nonstop discussion of AI. Every time I see it, I take an Advil and sigh. Everybody's wrong, There's going to be more. I'm gonna keep the makers of ibuprofen in business. Our biggest hope for you, me and my collaborators, is to help. Is that you'll be equipped with the knowledge you need to filter the hype and make sense of the substance. I want to give one final little shout out. This is a project that we've launched at the Allen Institute for AI, which is a nonprofit, independent research group based in Seattle. Next to the University of Washington. It's my second job. At AI2, which we call it AI2, we're building OLMO, Open Language Model. This will be the first modern language model where the data, the models, and the code are all shared openly. And we're hoping to make this a project that will bring in a lot more participants in the understanding and development of language models. The special twist with OLMO is that we're trying to be very concrete about who the users are. I think a lot of people will find it interesting and potentially useful, but the people we're really keeping in mind and the use cases we're developing around are scientists. So I think this new emerging technology is going to be incredibly empowering for advancing scientific discovery across many fields. I'm happy to talk more about that, but I'll wrap up and say, first I want to thank Sophia and Xander, two students at UW, who worked with me on the guide to the Perplexed, which is there's a document form to this talk, which will be made public soon. I want to thank my funders and the many people who work with me at UW and at AI2. Let me conclude. Current language models are perplexing. By keeping in mind the trends that have gone on in the natural language processing and machine learning research communities that have produced language models, I think you can gain a sense of why these models are behaving as they do, and they become a little less surprising. And keeping in mind the primary task that they were designed and trained to accomplish, which is predicting the next word, it helps us understand maybe more fundamentally how they work. There are still so many open questions about these models. I'm not going to retire anytime soon. But hopefully, as you go and use them and interact with them, you'll be a little bit better informed now. I refuse to make big predictions about the future, but I think there is a path forward for more of us influencing the direction that this technology has taken. And I'm hoping that you've learned something today that will help you engage with that. So I'm happy to move to questions. Thanks.
Thank you so much for coming out today. If you do have a question, we ask that you raise your hand, and one of us will come to you with a microphone. Please keep your remarks to questions and your comments to a minimum, and speak slowly and clearly into the microphone. Your first question's right in the front center here.
Hey, how are you? Thank you again for talking to us. I wanted your, let's just call it, it can't be objective. I wanted your opinion on ChatGPT. We heard you say it's not very open, OpenAI is not very open, but we also heard you talk about its benefits in the start of this. At work, we've been told, hey, don't put your work information into there. Obviously, it's open, people can see it. But what, just honest to goodness summarization of your thoughts on ChatGPT as a whole?
So ChatGPT was launched in late November of last year, and I had the great fortune to be in a service role in my community. I was the general chair of a conference that took place about a week and a half after that in Abu Dhabi. And the mood at that conference, I put a lot of work into this, okay? Like, this is a once in a career thing, and I was really excited. And the mood at that conference was bleak. I mean, people were despondent. Like, some of the students who hadn't been around the block so many times were like, what, is our field over? Is it done? Should we all go work on something else? Some of the senior people, like me, were like, is this what we have to deal with now? We're getting all this press attention. Suddenly this thing is out here. Is it, we knew it wasn't solved, but we knew that something had happened. I think something happened, and I think it's not an unmitigated positive or negative. There's new technology. It does some exciting things. It's captivated a lot of people's attention. 100 million users tells me that this is very exciting time, like way more exciting than anything I've seen in my field so far for the larger public. But the model's not perfect. It has problems. When I say OpenAI is not open, what I mean is they haven't, the details they've shared about the technology, they kind of clammed up. But prior to ChatGPT, they were talking a lot more. They would write papers and technical reports sharing a lot more details. These models, they're treating them as products. Whether they're open about the data that you upload into, what they're doing with your data, I would go read the terms of service. I can't tell you exactly. I certainly have no idea what they're doing with the data they are doing things with. I would assume that when they say they won't use your data, or if you can opt out, that you actually have opted out. I would like to think that. I am personally not uploading anything sensitive into this system. I kind of love this idea that one day you'll have your own language model, and it'll live on your device and nobody else will have access to it. And if you want to train it on your email to make it more helpful to you, great, it's yours. Nobody else can touch it, right? Just like your private photos, your other private data. That's where I'd like to be. But right now, unless you can afford a massive number of GPUs, this is, and have a lot of technical expertise, this is not happening for you. So I think I have mixed feelings about it. I think OpenAI made a big contribution to showing us what's possible, and they've certainly had other big technical breakthroughs that were very exciting. But yeah, they should change their name.
Okay, we have the next question right over here.
Hey there. Thank you for coming to speak with us. Very illuminating. And I think, at least for me and hopefully others here, it opens some vectors for further exploration. And so on that tangent, I want to get your thoughts. Two-part question. As you said that for everyone, they should consume news thoughtfully, right? What sources would you suggest we consume? Like, which ones would you recommend for us to consume to be thoughtful? And then secondly, on the specific topics that you brought up today, are there any specific sources to go deeper? Not just general news, but to go deeper on specific ones.
Okay. I'll take the second question first and say, I hope that the guide that we release in the next few weeks or months, hopefully weeks, will be a good jumping off point for kind of going deeper outside the news. We'll have references. It'll be hopefully a readable, but still proper citations and all that, and you'll have links out to other things to look at, and that I think will be a very good jumping off point. And we wrote it because we didn't think one existed. And apologies if there's something else great out there that I don't know about yet. I can only read so much. As for the news, Yeah, I mean, I'm not sure, what to recommend. I think there are some writers that that put a lot of thought into assessing the technology, and I found some of the writing. Everybody's wrong, but some people are like, a little less wrong. Or they give you insights, right? And there was this piece, I think it was in the New Yorker by Ted Chung on a blurry JPEG of the web or something like that. It was his metaphor, and it was thought-provoking. I don't want to say it was 100% right. Some people criticized it on technical grounds, but generally I found it very good. But for me, it's sort of like I found the writers that tend to get it right more often than not, and follow them rather than leaning on one particular press organization. I would steer clear of things that come directly from the for-profit companies. The press releases that they put out tend to just kind of overstate everything. The reactions to those are often way more interesting. I think if you read them, also wait a few days and see what the academics are saying about them, and the criticisms that come from the other companies, and somewhere in between you'll start to get some sense. I think I don't want to say trust anything that comes out of an academic group, but I tend to think that the questions academics ask can be illuminating. And so that's like another perspective, and often it doesn't get as much play in the press. There's kind of an attitude that all the interesting stuff happens in industry, but I don't think that's true, and I think some of the deeper questions that are more enlightening are coming out of academia, because we can take a little bit of a longer view, right?
Next question is right here in the center.
Yeah, so I'm interested. There are a lot of things cannot be resolved with simple questions. Like, for example, if two different experts in physics disagree on something, that could probably be resolved with a long discussion, but I can't think of how to express it as a simple question.
Yeah.
What happens?
Yeah, that's a great question. So, one of the interesting twists over the past year or so, there was this thing that it got branded different ways. I won't use the brand names. The idea was that you could get a more interesting response from a model if you kind of prompted it to break a question down into steps, right? So you'd say something cute like, "This is a complicated question. Please break it down into parts." If you were asking it to solve like a math puzzle or something, and people found that if you prompted it this way, and a number of tricks like this were published, you could get better results. The example you're giving of some fundamental question in physics that's under debate, you might try to say, please give me different perspectives on this question, and it might do it. It might also hallucinate them. I don't know. Sometimes it works, sometimes it doesn't. So certainly don't take what it gives you for now. Just think of it as I'm exploring, right? I want to see what it does. Don't assume it will get it right. But I think I agree that the idea that everything can kind of just come out through asking a question and getting a chat. I think a lot of researchers are very interested in sort of going beyond question answer to like ongoing discussion dialogue, right? Another piece to this is relying on next word prediction to do all of this work seems wrong. It seems like the model ought to have some tools at its disposal, like it should be able to call Google and ask a question and come back and say, here's a document that Google found, or some other search engine on whatever Google's. I think these are all things people are working on, right? So don't look at the thing that's been deployed as the final stage of where this technology is headed by any means. I think it's very interesting to think about, I asking the model, I'd like you to show me a conversation between 3 leading physicists about this particular topic, and have it like channel some personalities, maybe even put names on them. Could it do that? How would you train it to do that, right? I don't know. I mean, maybe if you trained it on lots of intellectual debates that were transcribed among the physics community, you could maybe get something. I'm not sure. But the idea that everything is question and answer, everything is just this next word continuation, it's certainly being challenged, and people are thinking way broader than that now.
Your last question is over again to your left.
Hi. Thank you again for your talk. It sounds like it would be possible if you wanted to ask people who lived in the past and they had extensive writing, so like Tolstoy or maybe Martin Luther King, like you could feed it all of their writing and then ask it questions. And so would this be a way to talk with minds of the past?
It would be a way to talk with something that sounded kind of like minds from the past, but I don't know that I wouldn't trust it to accurately represent their positions on things. It would be fluent in the way they were fluent. It might get the style right. It might even repeat things that they said. But we certainly would have no way of testing and verifying that it was accurately reflecting their positions on things, right? So it sounds like kind of interesting, but I would not describe it as interacting with those people. That seems disrespectful to them.